She cooked rice almost every night of her life. Not the kind that comes in a box with a picture of a finished dish printed on the front. The kind that started with a bag, a bowl, and her hands working through the grains under running water until the water turned cloudy and then, eventually, clear. I must have watched her do this hundreds of times as a child, sitting at the kitchen table doing homework while she stood at the sink. And I never once saw her pour that first cloudy rinse water down the drain. It went into a small jar instead. Always a jar, never a bowl, with a square of cheesecloth over the top held down by a rubber band. The jar sat on the windowsill behind the kitchen sink for a few days, and then it disappeared into the garden, and a new jar started the whole process over again. I asked her once, maybe 9 or 10 years old, what was in the jar. She said it was the water that feeds twice. I did not understand what that meant. I am not sure I fully understood it until decades later, standing over a cracked, lifeless pot of soil on my own back porch, watching water roll off the surface instead of soaking in, wondering why nothing I bought from the garden center seemed to bring that soil back to life. The pot had been beautiful once, store-bought potting mix, a name-brand fertilizer applied exactly as directed every 2 weeks, and still, somehow, the soil had turned pale and hard, pulling away from the sides of the container, repelling water like wax. I remember standing there thinking about her windowsill jar for the first time in 20 years, and I remember thinking, with something close to embarrassment, that I had spent more money trying to fix that soil than she had spent on her entire garden in a season, and her tomatoes had always tasted like something worth remembering. Here is what I eventually learned, and what I wish I had understood while she was still alive to ask about it properly. That cloudy rinse water was never just water. It was the beginning of one of the oldest, most quietly effective soil treatments in the world, used across rice-growing cultures for longer than anyone has kept written record, and only recently studied seriously by Western soil scientists. The mechanism behind it explains exactly why a store-bought potting mix, no matter how much fertilizer gets poured into it, can still fail to support a healthy plant. Commercial potting soil, the kind sold in colorful bags at every garden center in the country, goes through an industrial sterilization process before it ever reaches a shelf. Researchers at Colorado State University have documented that eliminating weed seeds and pathogens from raw peat and bark requires sustained temperatures well above 180 degrees Fahrenheit. That heat does exactly what it is designed to do. It kills every weed seed and every harmful organism in the mix. It also kills everything beneficial, the nitrogen-fixing bacteria, the mycorrhizal fungi that have partnered with plant roots for hundreds of millions of years. The entire living food web that healthy soil depends on to function, gone before the bag is even sealed. What gets sold is not soil in the way my grandmother would have understood the word. It is a sterile, biologically empty growing medium. It can hold a plant upright. It cannot, on its own, sustain one. This is the piece of information that explains why a fertilized plant in store-bought soil can still struggle. The fertilizer supplies isolated minerals. It does nothing to rebuild the underground community of microorganisms that, in living soil, breaks down organic matter, unlocks bound nutrients, and physically holds soil particles together in the loose, crumbly structure that allows water to soak in instead of running off the surface. Without that microbial community, soil eventually becomes exactly what I was looking at on my back porch: hard, pale, and hydrophobic, repelling the very water it needed. My grandmother's jar was solving this exact problem decades before anyone in my family had a name for it. Rice rinse water carries dissolved starches, B vitamins, amino acids, and trace minerals pulled from the outer layer of the grain during washing. On its own, fresh from the tap, it is mildly useful to a garden, a gentle, low-grade feeding. But left undisturbed in a covered jar at room temperature for 3 to 5 days, something else begins happening. Lactic acid bacteria, the same family of organisms that turns milk into yogurt and cabbage into sauerkraut, begin multiplying in that liquid, drawn in from the surrounding air and from the rice itself. They feed on the starches, they multiply rapidly, and as they multiply, they transform that mild rinse water into something considerably more potent. A concentrated, living, microbial drench. This was studied formally for the first time in the modern scientific literature in a 2021 paper published in the journal Sustainability, led by researchers Abba Nabai and Christopher Tay at University Putra, Malaysia, confirming what rice farming traditions across Asia had already understood for generations. A 3-day fermentation period substantially increases beneficial bacterial populations in the liquid and raises the available nitrogen, phosphorus, and potassium content measurably above what fresh rice water alone provides. Their follow-up research in 2023 documented measurable increases in nitrogen-fixing bacteria, phosphorus-solubilizing organisms, and overall plant growth in soils treated with the fermented liquid. Decades earlier, working independently on the other side of the world, a Japanese horticultural researcher named Dr. Teruo Higa at the University of the Ryukyus had already arrived at a closely related conclusion, formalizing the concept of effective microorganisms, a carefully cultured blend of beneficial bacteria and yeasts capable of restoring biological activity to depleted soil. Lactic acid bacteria sat at the center of his work, the exact same organisms that establish themselves naturally in a jar of fermenting rice water on a kitchen windowsill. The Western scientific world arrived at this understanding only in the last several decades. Farming households across rice-growing regions of Asia, the households that produced the food traditions my grandmother grew up cooking within, had been relying on this exact process for far longer than that, passed down not through journals, but through the kind of quiet daily repetition that turns a practical technique into something resembling instinct. She never read a paper on lactic acid bacteria. She knew the smell to wait for, and she knew when the jar was ready. Here is exactly how to recognize that moment, because getting it right is what separates an effective brew from a wasted one. The finished ferment should carry a faint, sour smell, clean and almost bread-like, similar to the smell of a sourdough starter on the morning it is ready to bake. A few small bubbles may be visible rising slowly from the bottom of the jar. The liquid often shows a slight separation, with a thin layer of cloudiness settling toward the base, while the liquid above clears slightly. These are the unmistakable signs of healthy lactic fermentation, the same signals a sourdough baker watches for, the same signals my grandmother apparently watched for without ever using that word. If the jar smells sharp, putrid, or distinctly alcoholic rather than mildly sour, something has gone wrong in the fermentation, and the batch should be discarded and started fresh rather than risked on a garden bed. The preparation itself could not be simpler. Rinse rice as usual before cooking, but instead of discarding the first cloudy wash water, collect it in a clean glass jar, filling the jar roughly 2/3 full. Cover the jar loosely with a breathable cloth or a paper towel secured with a rubber band, never with a sealed lid, since the fermenting bacteria need airflow and a sealed container can build dangerous pressure. Place the jar in a dark cabinet or a shaded corner of the kitchen at room temperature, away from direct sunlight and away from the refrigerator. Leave it for 3 to 5 days, checking periodically for that faint, sour, bread-like smell. One detail rarely mentioned matters more than it seems. The water used for the initial rinse should be cool or room temperature, not hot from the tap. Hot water can break down some of the B vitamins and starches before they ever reach the ferment, weakening the finished product. A quick rinse under cool water captures the cloudiness that makes the entire technique work. Once the ferment is ready, it is not yet finished. The most important step, the one that most people attempting this for the first time get wrong, is dilution. Undiluted fermented rice water is acidic enough to stress tender root tissue, particularly in young seedlings. The correct ratio is 1 part fermented rice water to 10 parts plain, non-chlorinated water. Mixed at this strength, the liquid is gentle enough to apply to the base of nearly any plant in the garden, from a struggling potted herb to an established tomato vine, without risk of root burn. Pour it directly at the base of the plant, soaking into the soil, never onto the leaves. Apply roughly every 7 to 10 days during the active growing season. And here is the second mistake worth naming clearly, because it explains why some people try this once, see little result, and abandon it permanently. Letting the ferment sit too long, 5, 6, 7 days or more, does not make it stronger. Fermentation that runs past the beneficial lactic acid stage slides into a different kind of decomposition, one that can produce compounds mildly damaging to young root tissue rather than beneficial ones. 3 days is the target window in warm conditions, stretching to 4 in cooler weather. Beyond that, the batch should go into the compost pile rather than onto a plant, and a fresh jar should be started. What this liquid actually does, once it reaches the root zone of a plant growing in depleted or sterile soil, is worth understanding clearly, because it explains why the results often surprise people who try it for the first time on the worst, most neglected pot in their collection. The lactic acid bacteria and the wild yeasts present in the ferment do not feed the plant directly the way a synthetic fertilizer does. They feed the soil's biological community. Within roughly a week of consistent application, the population of beneficial microbes surrounding a treated plant's roots can triple. Those microbes begin breaking down organic matter trapped in the soil, releasing minerals that were chemically locked and unavailable to plant roots, and producing compounds, including certain B vitamins, that directly stimulate root development. The soil itself begins to change, slowly at first and then more visibly. Compacted, hydrophobic dirt that once sent water sliding down the inside of a pot begins absorbing moisture instead, because the bacterial activity restores the porous structure that healthy soil depends on. Within 2 to 3 weeks of regular applications, a pot of soil that once felt hard and pale begins to feel different to the touch, darker, looser, faintly sweet-smelling, the way soil is supposed to smell after rain. This is essentially what was happening quietly in my grandmother's garden beds for the better part of 50 years, long before anyone had attached scientific language to the process. She was not running careful trials or reading peer-reviewed journals. She was repeating something her own mother had done, something practical and unglamorous that happened to be biologically sound, validated decades later by researchers working in laboratories on the other side of the world from her kitchen. There is something worth sitting with in that. A jar on a windowsill, refreshed every few days without ceremony, doing more for the long-term health of a garden bed than anything sold under bright lights in a store aisle. Not because the science is mysterious or the ingredients are rare, but because the process asks for patience rather than money. And patience is precisely the thing most modern gardening advice has no interest in selling. My own jar sits in roughly the same spot hers always did, behind the kitchen sink, cloth-covered, waiting out its few days before the next application. The pot on the back porch that started this whole search, the one with the cracked, water-repelling soil, absorbs water evenly now. It took about 3 weeks of regular applications to get there, not overnight, and not without a little doubt along the way, but it got there. And every time I pour a fresh batch around the base of a plant, there is a small, specific thought that arrives without being invited. The tomatoes might just start tasting like the ones she used to grow. If this kind of patient, rooted knowledge is what brought you to Rooted Grace, the like button and the subscribe bell keep this work going every week. Leave a comment below and tell me about a gardening habit someone in your family passed down to you, something that seemed unremarkable at the time, but that you now understand differently. I read every one of them, and I would love to know what's been sitting on someone else's windowsill all these years. The next video in this series goes further into what happens underground once this kind of microbial activity establishes itself, including the role earthworms play in finishing the work this liquid starts. That one is coming next week. Until then, save the rice water, find a quiet jar, and let it tell you when it's ready.